Hello friends, in last two sessions I have told you about working of turnout and also what are different types of track junctions that can be formed by different combinations of points and crossing. Today in this session we shall discuss the design of a turnout. Now design basically means determination of different distances which are required for laying of a turnout. Now this is a turnout. Now here what I told you in my last session, this is the point, a pair of point. Here you have the heel divergence D, this is the tongue rail, and here is the crossing. This is the angle of crossing. Now design means determination of different distances, and distances are, first is the curve lead, curve lead is measured from this tangent point, that is top of the switch, to the theoretical nose of crossing. This is called T and C, theoretical nose of crossing. Now this distance is CL, curve lead, measured along the main line. Then distance between this heel and the top of the switch, that is called the switch lead. Switch lead. This is also measured along the main line. And this distance from heel of the switch to the theoretical nose of crossing, that is called crossing, length of crossing or crossing lead. Crossing lead. Now these three parameters are estimated in the design of a turnout, and a simple turnout will assume that the curve starts from a point which is slightly ahead of the top of the switch to the theoretical nose of crossing, TNC. So the curve starts from a point which is theoretical top of the switch and it ends at the theoretical nose of crossing. Now this type of design will have three kinks. The first kink is at top of the switch because the curve is not tangential at this point. Second is at heel of the switch because this tongue rail is straight, it is not curved, and therefore it is not tangential to the curve. And third is at TNC because this frog is not tangential to the curve. This point rail is not tangential to the curve. So this design, which we call the Coles method, consider all these three kinks, one at toe, another at heel, and third at frog. That is the point of crossing. This is angle of crossing alpha, and if you draw a tangent here and another tangent to this curve is naturally this line, and let's put some name here. Let us say A, B, this point is, let us say, P, and here you can write S, T, and this is the, let us say, radius of the curve, a point O here. Now radius of the curve is the radius of the outside curve. So this is radius, complete radius, R. This is R. And if you join these 2 points A and S by a straight line, then this angle, total angle is alpha, this angle is alpha. This is the point P from where you draw two tangents PS and PA on the same curve, and therefore their lengths are equal. So this length AP is equal to PS, and therefore this angle will be equal to this angle, and because sum of these two angles is alpha and therefore this is alpha by 2 and this is also alpha by 2, and therefore this remaining angle here, this angle is alpha by 2. That is from simple geometry. And if you consider this triangle AST, cot of alpha by 2 will be AT upon ST. ST is the gauge of the track, and therefore an AT is your curve lead, and therefore CL will be gauge into cot alpha by 2. Now this curve lead CL can also be written as BP plus PS. BP plus PS. And I told you PS is equal to PA because they are two tangents drawn from the same point. So this is PB plus PA or AP. This PB is G cot alpha, and this AP will be G into cosec alpha. Same triangle. And in case of turnout, in case of design of turnout, number of crossing is related with alpha by this relationship. That is called right angle triangle method. That is, the angle of crossing is related with the number of crossing. N is equal to cot alpha. N is the number of crossing, 1 in 8.5, 1 in 10, 1 in 12, like that. So this is Gn plus G into square root of 1 plus cot square alpha, and this is again 1 plus n square, so Gn plus G into 1 plus n square. That is the curve lead, second equation for curve lead. You can also write 1 plus n square equal to n square because it will be approximately, because n is large. So 1 plus n square may be taken as n square, and therefore it will be 2gn. CL is equal to 2gn. Similarly, we can find this CL by third method also by considering this triangle ATO. Now this is R, this is CL AT, and this is radius, total radius minus the gauge. So OT is R minus G, OA is R, and AT is CL. And you take right angle triangle here, and you can find out what is the value of the CL. CL will be in that case equal to 2RG. Approximately, CL will be equal to 2RG, square root of 2RG. Now, the second parameter is to determine the switch lead. Now, switch lead is this distance, starting from theoretical toe of switch to the heel divergence. This is heel divergence here. That is the total length of the tongue rail. And this can be done in, let us say, this is a small d, that is your heel divergence. So if you consider this part of the triangle now, let us say this point is E, this point E, and this point is, let us say, F. This is now R minus D. D is heel divergence. This is radius R. And again in this triangle FEO, you can find out what is EF. Similar to what you did in case of CL. So R square, that is FO square, is equal to SL square plus R minus D square, or SL square plus R square plus D square minus 2RD. R square is eliminated, D square is very small as compared to 2RD, and therefore SL is square root of 2RD. D is known. If D is not known, switch lead is known. In that case, you can find out what is small d. Hill divergence is generally fixed. And the third is this crossing lead, L. L will be from the Hill divergence to the theoretical node of crossing. So it is CL minus SL. L is CL minus SL. Another important consideration here is the radius of the curve. Radius R. Now this R you can take SO. SO is ST plus TO. ST is the gauge, G plus TO. TO you can find out from this triangle. This is alpha, same as the angle of crossing. From this triangle ATO, from triangle ATO. Now AT is crossing lead, that is your CL, and this T will be AT into cot alpha. AT is CL, and CL we found as 2GN, or rather you can say that GN plus square root of 1 plus N square into G. That was the accurate value of CL. Now if you put it here, it will be 2GN square because cot alpha is N. So this will be 2GN square. But after this approximation, that 1 plus N square is equal to N square. And therefore, a more correct value of radius will be 1.5G plus 2GN square. That is how you can find out the value of radius. Now this is the radius of outer curve. This is the Colles method, which basically consider all three kinks in the design, and therefore this method is used only for unimportant lines, particularly in yards where speed is extremely low. An improvement to this method is the second method. In this method, it is assumed that the tongue rail is tangential to the curve, and therefore the curve starts from heel of the switch. The curve starts from this point and it ends at theoretical nodes of crossing. This is the angle of the switch, beta, and curve starts from this point. So let us say again A, B, and this is C, and this point let us say D. So your radius of the curve now O is R, and this angle is beta, this angle is alpha, and therefore if you join these chord here, this angle here will be alpha minus beta. This is a tangent drawn to the curve from 2 points, and C is the point where these two tangents meet. Therefore, this angle will also be alpha minus beta, and again by the same philosophy that these are two tangents drawn from the same point on the curve, and therefore their length is equal, CA is equal to CD, and therefore this angle is equal to this angle, and that will be alpha minus beta by 2, and therefore this angle will be alpha plus beta by 2, a small angle. So instead of alpha by 2, now alpha plus beta by 2. Alpha is the angle of crossing, beta is the angle of switch. And that angle depends upon the length of the tongue rail. Now if you go by the same philosophy as we did in the first case, now this is G minus D, that is the gauge minus heel divergence, and therefore the crossing lead. Now crossing lead will be only this distance, there is no, this is crossing lead, L. G minus D into cot alpha plus beta by 2. In this triangle, this is the crossing lead. You can write here E, A, D, let us say F, this point F. So AF is the crossing lead, and this is G minus D into cot alpha plus beta by 2. That is your L, crossing lead. Switch lead is not a parameter now because tongue rail is curved, and curve now starts from the heel of the switch. Radius of the curve, take this. This point here. Let us say this point is T. T point is on this chord AD, right? So you consider this triangle ATO. So in this triangle ATO, this angle will be alpha minus beta by 2. Alpha minus beta by 2. And sine alpha minus beta by 2 will be 80 upon R. That is AO, R. And 80 is half of AD. AD you can find out from this triangle, AD from triangle ADF, and that is sine alpha plus beta by 2 is equal to this G minus D upon AD. And if you put all these values, you will get R is equal to G minus D upon cos beta minus cos alpha. That is the value of radius of the curve. So radius of the curve and crossing lead you can calculate in second method. Here one kink is removed, and that is at heel of the switch here. This remains. Now in the third method, which is generally adopted on Indian Railways, that is called IRS method. This kink at the crossing is also removed, but by providing a straight arm which is tangential to this curve. A straight arm is provided here, and your curve starts from heel of the switch and it ends at this point. So this arm is also tangential to the curve now. So one kink is removed at this point because tongue rail is made tangential to this curve, and another kink is removed at this point because this arm, straight arm, is also tangential to the curve. Only one kink remains at top of the switch, and that cannot be removed by any improved method of design because it's a suddenly change in the alignment. Now in this case, this is the curve now. This is the curve. It tangential to tongue rail at this end and tangential to the straight arm at this end. And if you go by the same calculations as we did here, the only difference is now that this is G minus D. Sorry, this is D. This angle is alpha. So this is X sine alpha. So this is G minus D minus X sine alpha. This distance. And similarly, your crossing lead by calculation it will be this much, and you can add here this distance x cos alpha. This is x cos alpha. So crossing lead will be, in place of g minus d cot alpha plus beta by 2, it will now be L is equal to g minus d minus x sine alpha into cot alpha plus beta by 2 plus x cos alpha. That will be the crossing lead total. This you calculate and this you add. Because crossing lead is again from Healy switch to the theoretical laws of crossing. And this radius will be, in place of g minus d, you write g minus d minus x sine alpha divided by cos beta minus cos alpha. That is your radius of the curve. These are three methods of designing a turnout. Coalesce method is used on unimportant lines, and this method, IRS method, is used on all important lines. So friends, thank you very much for watching this video. You can have your comments and suggestions in the comment box.